everyone, welcome back to this channel. We are studying class 9 science. In that, chapter number 9, force and laws of motion. Now, till the previous video, we have covered all the theory topics as well as blue index questions also we have solved. Now, in this video, we are going to study about the exercise questions. In that, theoretical questions are also there. Also, we have numericals. So today in this video, this will be the first part of the video. So we will see up to question number 10. So see very carefully all the steps and then solve it in your notebook. So now let us start with question number 1. Question number 1 is an object experiences a net zero external unbalanced force. Is it possible that the object is traveling with a non-zero velocity? If yes, state the condition that may be placed on the magnitude and direction. And if no, provide a reason. Now this question is very simple. They are asking if there is no unbalanced force acting, can the object still be moving? So the answer is yes. How? This is possible only when the object has been moving with a constant velocity in a particular direction. See, when the object is moving at a constant velocity, we can say that the velocity is neither decreasing or increasing. That means no unbalanced force is acting. That means external force is zero. Then and only then it will move with constant velocity. Then if the object is moving at a constant velocity, no net unbalanced force is applied and the object will keep on moving with non-zero velocity only. Neither increase nor decrease. Right? So this was the first question. Now question number 2. Very important. When a carpet is beaten with a stick, dust comes out of it. Explain. Now you have to imagine a situation in which there is a carpet, right, held vertical. That carpet is along with the dust particles, right? Dust particles is there in the carpet. Now what happens? We will have to use the concept of inertia, right? That inertia always tends to resist any change in state of rest or state of motion. Now, when a carpet is beaten with a stick, then the carpet comes to motion, right? With the stick, the carpet moves, but the dust particle due to inertia, they will try to resist their state of rest. So they will stay as it is. But if the carpet is moving, the dust will remain hanging in the air and thus they will fall. So according to Newton's first law of motion also, the dust particle will stay in the state of rest while the carpet is moving. So dust particle will fall and they will come out of the carpet. Clear? Question number 3. Why is it advised to tie any luggage kept on the roof of a bus with a rope? Right? That means when we are carrying any heavy luggage and we are putting on the roof of the bus, we are not leaving as it is. We had to tie it. We have to give it a support. Now why? Again the answer lies in the inertia. When the bus accelerates and moves forward, it acquires a state of motion. Remember, the bus acquires the state of motion. But the luggage kept on the roof due to inertia will try to remain in the state of rest only. So what will happen? With the forward movement, that luggage tend to remain at a original position and ultimately it will fall from the roof and thus it may injure us also. That is why to avoid this situation, it is advised to tie the luggage kept on the roof of a bus with a rope. In short, we have to provide a support so that it doesn't fall off due to its inertia. Okay. Now, question number 4 is an MCQ. A batsman hits a cricket ball which then rolls on the ground and after covering some short distance, the ball comes to rest. Very simple observable phenomena. Now they are asking the ball slows down and stops because the batsman did not hit the ball hard enough. Wrong. Velocity is proportional to the force exerted. No, because we have seen Archimedes, we have seen the Aristotle or Galileo's contribution. All the concepts says that whenever the object is moving with constant velocity, it will continue to do so unless there is some kind of opposition. right? So you see option C very carefully. There is a force on the ball opposing the motion, and which force it is? It is a frictional force, right? The cricket ball is moving with the help of the force given by batsman, but ultimately it will stop because friction is acting opposite to the motion, so it will stop the ball after some distance, right? So frictional force is responsible, so option C is correct. Now moving on to next question. Now from here we have to calculate. So be ready with your notebook and all the materials. So step by step we will see. A truck starts from rest. Starts from rest. So initial velocity will be 0. Rolls down a hill with constant acceleration. We are not given with that acceleration. It travels 400 meter in 20 seconds. Find its acceleration. Also find the force acting if the mass of truck is 7 metric ton. Now 1 metric ton is 1000 kilograms, so 7 metric ton will be 7000. So quickly let us prepare the list of what is given. Initial velocity u 0 meter per second. Time taken is 20 second. Distance covered 400 meter, that is s. As per the second equation of motion, we know that s equals to ut plus half at square. Why we have used this equation? Because we are finding acceleration. What is given? S is given, U is given, T is given, only A is left. So A we will find. Putting all the values, it will be 400 equals to 0 into 20 plus half into A will remain as it is, and T square will be 20 square. So first term will be 0 only because it is 0 into 20. So 400 equals to half into 20 square. So you see 400 equals to 200A. So 200 will go below 400 and will be A equals to 2 meter per second square. So acceleration is 2 meter per second square. Now we have to find out the force acting. So force is mass into acceleration. Putting all the values, mass is 7 metric ton, so 7000 kilogram. Acceleration is 2, so 14,000 Newton. Clear? Very easy. Moving on to the next one. Question number 6. A stone of 1 kilogram is thrown with a velocity of 20 meter per second across the frozen surface of a lake. It comes to rest after traveling 50 meter. What is the force of friction between the stone and the ice? Now see, initial velocity is u, that is 20 meter per second. Final velocity after it comes to rest, it will always be 0 meter per second. What is the distance covered? 50 meter. According to third law of motion, or third equation of motion, v square minus u square equals to 2as. Right? So putting all the values, v is 0 square, u square is 20 square, 2 into a we are finding, s that is displacement 50 meter given. So minus 20 square equals to 2 into a into 50. So the final answer will be a equals to minus 4 meter per second square. Right? So till now we have found only acceleration. Why acceleration? Because we are finding force, and force is mass into acceleration. Okay. Now it is very simple. Negative sign, why it is negative minus 4? Because the force, the acceleration is acting against the motion. So only direction is opposite. So we will keep minus 4. Now mass is 1 kilogram. So second law of motion, F equals to ma. We will put all the values. What is mass? 1 kilogram. A minus 4 meter per second square. So final force acting, or the force of friction acting between stone and ice, is minus 4 Newton. So what is the frictional force? Minus 4 Newton. And we know that frictional force always act opposite. So that is why negative sign is there. Clear? So you see, we are only using the concepts of motion and the formula that we have learned in chapter 8 and 9 till now. Okay, so that is why numericals are very easy until you make a list of given, understand the question properly, and then remember the formulas as well. Moving on to the next question. Now the next question is a little bit lengthy one, but try to understand very easily. We will try to solve it. An 8,000 kilogram engine pulls a train of 5 wagons, right? Wagons, the coaches that are there. So 5 wagons and 1 engine, total 6 things are there. Each wagon is of 2000 kilogram. If the engine exerts a force of 40,000 Newton and the track offers a frictional force of 5,000 Newton, then calculate the net accelerating force. You see, main force is 40,000 Newton and frictional force, that is opposite. Remember, frictional force is opposite. So we have to cancel that 5,000 from the total. Right. So you see, force exerted F 40,000 Newton, frictional force FF I have written, frictional force, right, 5,000. What is the overall accelerating force? So it is F minus FF. So 40,000 minus 5,000, 35,000 Newton. So overall only 35,000 Newton force is acting. Clear? Now going on to the second part, acceleration of the train. So let us find out it by a simple formula, F equals to ma. But we don't know what is the total mass. Okay, so we will step by step see. Acceleration, let us suppose A. Net accelerating force is 35,000 Newton. Just now we have seen. One wagon weighs 2,000 kilogram. Number of wagon is 5. So how much will be the mass of all wagons? 10,000. Plus engine and wagons will be total 18,000 kilogram. So overall we got total mass. Force we are having 35,000 Newton. So now it is very easy. F equals to ma. We are finding A, that is Fa upon m. So 35,000 upon 18,000, and that is roughly near to 1.9. Okay. So acceleration is 1.9. Okay. So now moving on to the third part, the force of wagon 1 on wagon 2. This is a tricky question. See, mass of 4 wagons excluding wagon 1. So it will be 20,000, 2000 into 4, that is 8,000 kilogram. Acceleration we already have calculated, 1.944 meter per second square. So what will be the force? F equals to m into A. Mass is 8,000, A is 1.944. Final answer will be roughly around 15,552 Newton. Right? Because we are talking about force of wagon 1 on wagon 2. So wagon number 2, 3, 4 and 5 will be added. The 8,000 is the mass of those 4. Right? And acceleration we have got from the part B. So just very simple, m into A will give you the answer. Clear? Write properly, understand the question properly. Moving on to question number 8. An automobile vehicle has a mass of 1500 kg. What must be the force between vehicle and the road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? So mass is given, acceleration is given, and we are finding the force. Okay. So very easy. Let us make the list of what is given. 1500 kg. Final velocity is 0 meter per second. Acceleration minus, right, negative acceleration. Remember. So minus 1.7 meter per second square. From Newton's second law of motion, we know that F equals to ma. So mass is 1500, acceleration minus 1.7. What is the final answer? It is minus 2550 Newton. So this is our answer. Very simple. Now, question number 9. What is the momentum of an object of mass m moving with velocity v? So it is nothing but the formula of momentum. Options are given, mv whole square, mv square, half mv square, mv. And we know the correct answer is mass into velocity. Okay? Mass is m, velocity v, momentum equals to m into v. Clear? Now last is question number 10 for this video. Using a horizontal force of 200 Newton, we intend to move a wooden cabinet across a floor at constant velocity. What is the frictional force? So it is very easy. 200 Newton is applied in forward direction. From Newton's third law of motion, equal amount of force will act in the opposite direction. So opposing force is the frictional force. So what is the frictional force exerted? It will be 200 Newton only, but in the opposite direction. Clear? So this was the end of the 10th question. In the next video we will see another remaining questions also, right? So till now, make the notes properly, write all the steps, solve the numericals very carefully and watch the video completely. So that's it for this video. Thank you.